So in the last video I said I didn't have any more hardware stuff to do, but I do have a little bit more hardware stuff to do. So this is the additional circuits I need to add, and I'm using Draw.io as my drawing tool for the circuits here. So what I wanted to add was, as well as having the MIDI output going through a 5-pin DIN plug, is also be able to have a CV output going to analog synthesizers. So basically having a voltage and a trigger going out to analog synthesizers. So the way I did that is added two main components. To get the control voltage, I added an MCP 4725, which is a 12-bit digital to analog converter. If that ranges over 5 volts, that's basically 5 octaves, and 12 bits over 5 octaves should give me fairly accurate notes. We'll see what that sounds like when I connect it up. The MCP 4725 runs on I2C, so I'll be using the same I2C bus that I used to run the OLED. I'll also connect it up to the digital to analog converter. It'll have a different address, so that should all work off the same bus fine. And then the other part, to having control voltages run synthesizers as well as having the control voltages, you need a trigger signal. That's usually 5 volts for Eurorack synthesizers. The output from the Raspberry Pi is 3.3 volts, so I'm going to use bi-directional level converter. It's basically going from 3.3 volts up to 5 volts, and the other way as well, to allow me to have a 5 volt trigger out. And the other thought is getting some feedback from the first design is have some way of triggering the PIMidi code. So I'm also going to have a trigger in, so coming in at 5 volts, and triggering a GPIO pin at 3.3 volts, and this would be a good way of doing sort of sequencing tasks where say a trigger comes in to fire off a sequence in Python, and have that go out on the MIDI or as control voltages. That's the plan. I got to see whether I can fit the whole thing into my Eurorack panel that I 3D printed. I think I got room for it, so let's try that out, see if we can get it fitted and see if it actually works as well. So first I wanted to clean up my Eurorack panel. At the moment it's just straight 3D printed. It's got all the groove lines from the 3D printer on there. So first what I did was put a layer of epoxy over the front, which I'm going to sand down. So I just used some old epoxy that I had hanging around, which seemed to do the job. It was fast setting, dried pretty fast, so I just spread that over the front. I kept it fairly thin. I really just wanted to fill in the main grooves from the 3D printing. So I got that all on, just cleared out some of the holes, and it dried in about 15 minutes, at least dried enough that I could then sand it. Then the next stage after that was I sprayed on some filler, sanded that down, then sprayed on the actual green panel paint, and then put some transfers on it for labels. To make using this a little easier, I added some code so that after powering on, it'll show the IP and the host name and the OLED. It'll give me a better indication that the PIMidi's running. Set up this service that runs at startup in the setup bash file. So I added this step 6, and I've created this PIMidi.service file that gets copied out to systemd system PIMidi service. I char mod on that so it can be run. I do a system control, which is the thing that runs all the services on Linux, and I enable that service. And then I reload the system control as well, so it takes effect. And what's in that service file, if we go to PIMidi service, so this is just the standard service file. So the important things here are to say this starts up after startup of the Raspberry Pi, and also after the network started up. And I've also had to add in this little routine here, exec start pre, so it won't actually run the service or the Python program associated with the service until it gets a valid ping back from google.com. So this just makes sure that the network's up, and then the actual service it's going to run is this one here, which is in my PIMidi directory called PIMidi Pi. Let's have a look at that. So this is what gets run at startup. So at the moment, all it's going to do is show the IP and hostname in the OLEDs, which indicates the PIMidi is ready to be used, but longer term this will actually fire everything up in the web's service and have it all ready to run PIMidi on the PIMidi device. So what's this doing? It's really just a variation on my OLED test. So a lot of the same code in here, but it's also getting the IP address and the gateway and the host name from the socket. So that's why you need the network up, and then it displays the host name and the IP address on the OLED. So that indicates that Linux on the PIMidi is successfully started up, and it also gives me the IP address, which is sometimes useful if I can't connect through the host name, or I've forgotten the host name. I can use the IP address to connect to it, and eventually it'll have a web server running on that IP address, which will be how I interface with the PIMidi. So this is what I'm going to do to build the additional hardware circuit. So you've seen the circuit diagram already. I think this board should be the right sort of size for it, and it'll fit next to my Raspberry Pi W into the Eurorack panel. And I think I should have enough room on this board to put a Eurorack power connector here, so I can just run a cable into the Eurorack case. And then the two pieces that I need is the MCP 4725. So I'm going to use that raised off the board using this little pins and sockets. Raise them off the board, and then I can run some wires underneath here, I think, for running the wires from the power, and then plug it in afterwards. And the other thing was the bidirectional voltage converter going from 3.3 volt up to 5 volt. And again, I'm raising off the board so I can run some wires under there. And the reason I'm doing all that on that side of the board is so if I need it, I can also put a couple of op amps. So this is a dual op amp IC. I'll have room on the board to fit that if I do need to do something with adjusting the power coming out from CV. At the moment it's going to swing from 0 to 5 volts, but I may want it to swing over all the octaves, so maybe 0 to 8 volts or 12 volts even, in which case I need an op amp to amplify that signal from 5 volts up to 8 volts or 12 volts, whatever sort of swing I want. So this op amp and a couple of potentiometers on the board will allow me to adjust the swing and the starting voltage. So that's the idea. So let me try wiring this up and we'll see what it looks like. Is it wired up? Looks good, so I just need to test it. I've still got room on the proto board for some op amps if I need it. Okay, to test that the control voltage triggers were working, so I know I changed them to the GPIO 23 and 24 on the Raspberry Pi, and I'm also going through the level converter going from 3.3 volts to 5 volts, so I want to check they're wired up right and they're getting the right voltage out. So I put together this script, which is really just a cut up version of the GPIO script, and all it's doing is toggling channel 23 GPIO out between high and low 3 times, and then doing the same for channel 24. And I just run it like this, and I've got an oscilloscope connected up to the trigger outputs, and let's have a look at that. So I connected up the two trigger outputs at the moment to my oscilloscope. Channel 1 was GPIO 23 and channel 2 should be GPIO 24. So I confirmed that when I see GPIO 23 as the first one that gets toggled. Then I also wanted to check the voltage swing was between 0 and 5 volts, that the level changing is happening correctly, and that looked good. Okay, one more test. I'm just going to check that I can get trigger in values as well. So for GPIO 23, I've got it set up so I can connect it to a high or low voltage. I've got this little routine set up now, so it's going to change channel 23 or GPIO 23 to be an input, and just read the value every half second. So let's try running that. So let's move it to a low voltage. So that's good, it could detect it fine. Last piece of new hardware I need to check is that the MCP 4725 digital to analog converter's working. It's connected up to the same I2C bus as the OLED. So let's check whether we can see it and whether we can program it with Python. Okay, first I want to make sure I can see the two devices on the I2C bus. To do that, I've installed the I2C tools, and I've also added the line to the bash setup bash script to get those tools installed now. And the tool I'm going to use, the I2C detect here, and check on bus 1. Let's run that. And that's good. We can see two devices on that bus 1, so there'll be the OLED and the I2C, and the DAC. So now let's see if we can connect to the DAC and change voltages using Python. Now at this point I suddenly had to do a whole bunch of refactoring. Up to now I'd been using the Luma's libraries for doing OLED work, but now I want to do other things on the same I2C interface. I decided I'll switch over to using Adafruit's set of libraries, so they have one for both OLED and DACs, and it's simpler just having the same underlying technology used for both. So you'll see I've had to make some changes to refactor everything to just use Adafruit's library for all my I2C peripherals. Documented the changes again in my PIMidi setup script. So I took out the Luma install of the libraries, and now step 4 installs the various Adafruit I2C utilities. So I install Adafruit's support for the SSD 1306 OLED, and I also install the libraries for Adafruit's MCP 4725 DAC libraries. So with that installed, I went back and rewrote the OLED test. So basically I just stole the code that was already out there from Adafruit, and so I now connect via I2C to the SSD 1306, put in the correct address for it, and then just test that I can still do a hello world that worked correctly. So I think we're all set there. The other thing I had to do, I saw beginning of this video, where I'd set up a service to fire up when the Raspberry Pi fires up to show the IP address. So I had to swap out what was the Luma version of showing that on the OLED to using the Adafruit version. One unusual thing here, because it's running as a service, doesn't really know where the Adafruit information for the fonts are. I had to hard code that into this text just for this PIMidi that gets run from systemd. And now, getting back to what I was trying to test out, was making sure I could use the DAC. So again, I really just used some of the code that was already out there for using MCP 4725. So I set that up, set up a DAC object using the address of the DAC. So remember we saw the DACs on address 60 on the I2C interface. Set up some information. I also wanted to check that I could see in CV voltages at the same time as I was updating the OLED, that the two didn't clash. So I also brought in the OLED interface here as well, so just like we just saw in the OLED test. And then the actual test is, it just runs continuously, increasing the voltage on the DAC from 0 to 5 volts. And I'm also displaying going up on the OLED at the same time to test that they both can run at the same time. And then same thing going down from 5 volts down to 0 volts, and same going down on the OLED. So let's run that, see if this works. So here we see the oscilloscope connected up to the CV output. We're seeing the output going up and down, and we see the OLEDs getting updated at the same time. So to test everything out, that CV and MIDI would work together, I put together this little test routine called CVMidi, basically bringing in the libraries for both CV and the MIDI and the GPIO. And this is what it does. So it's basically running through a series of DAC values going from 0 to 769, which turned out to be about an octave's worth, and doing them in a step of 64, which is about a semitone's worth of steps. So I use that against the CV to have that go up in ascending values, this DAC raw value, which is X. And at the same time, I'm using the MIDI interface just to descend in semitones as well. And I'm also getting the GPIO to turn on and off the trigger. So for 0.2 of a second, it's turning on the note for both the CV and the MIDI. And then for half a second, it's turning off the notes. So let's run that and see what it sounds like. So I'm happy. My hardware seems to be working. I can play notes using CV and MIDI. So next steps mainly in the software area. So first I want to create a basic note playing routine and a way of updating settings. So I'll probably put in some web services to do that, and then put an Angular application over the top. After that, once I've got the basic application going, then I can also do things like add another function to be a basic sequencer. I'm also thinking I'll probably add a function to allow me to talk to Chat GPT and get it to create music and play it. And finally, I'm also thinking that I'd like to have a way of sending MIDI instructions to set up things like envelope settings and tone settings and things like that, so I can just have voices saved and then just run the MIDI to set those on the little Korg synthesizer there. So that's going to take a few videos to do, but that's the plan for the next few, is just delve into the software side of this, because I think the hardware's all set up, ready to go.